Okay, I'm going to work on chapter 5, question 4. It is about calculating the line of regression without using the linear regression function in our calculator. I'm using a different calculator than you're used to seeing in class. I apologize for that, but I don't have access to the 84 software on my computer. The first thing that I look at is the problem asked me to use software to find the mean and standard deviation of both the temperature and the growth. So I need the mean of x and y, and I need the standard deviation of x and y. So instead of using one var stats, I'm going to use two var stats. And then it wants us to find the correlation between that. So what I'm going to do is in my calculator, I'm going to go ahead and run my one var stat or two var stats. So you would press stat, calc, and down to two var stats, which is the second one, and you want to make sure you pull from L1 and L2. So my first one, and second one, and so for our X bar was 26.4667. They wanted it to 4 decimal places, 26.4667. Our standard deviation of x right here is 0.2251. The y bar right here, the average of y is 0.86. And then y bar, let's see, s of y, just a little bit. There we go, 0.0438. And then R, I'm not going to find in this page. I need to calculate the linear regression. So you would press stat calc number 8 to go to linreg a plus bx. So I'm going to do a statistics calculation, linear regression a plus bx. Oops, it disappeared. All right, and so then my R value is negative 0.8111. Okay. Then it says use these basic measures to find the equation of the least squares regression line. Now remember, this is not using A and B here. They want us to use the fact that B is equal to R times Sy over Sx. I don't know if you guys can see that right there. So what I'm going to do then is I'm going to take R, which was negative 0.8111, multiply that by the standard deviation of y, which was 0.0438, and I'm going to divide that by the standard deviation of x, which was 0.2251. So my B is now negative 0.1578, and it was to 4 decimal places. Now that we have our B, we can calculate A, and it was A is equal to y bar minus B x bar. I can put a little space in here so you can kind of see what I'm saying. So y bar, excuse me, was 0.86 minus B, we just calculated, was negative 0.1578 times x bar, which was 26.4667. Now we have A as 5.03645, rounding that to 4 decimal places, 0.0364. The best explanation that describes in words what the numerical value of the slope tells you. Slope right here, remember it's for every 1 unit in the x direction. If you go back to the original problem, our x was sea surface temperature. So for every one, what is it measured in? Sea surface temperature is measured in degrees Celsius. So for every 1 degree Celsius, we're actually going to decrease 0.1578 coral growth per year. When I'm looking at my statements here, I need to make sure that for every increase in sea surface temperature of 1 degree Celsius, so that's eliminating the last two, so I have the first two options, will result in an average of, I have to choose between fewer or more. Now because my slope is negative, it's going to be fewer coral growth per year. And that is how I would complete this problem.